Hi, everybody. Well, thank you for joining and welcome to the second session in the Hot Topics in Commodities series this year. And today we're going to take a look at canola, and this session is, it's presented to you by the Western Producer. I'm Mike Raine, editor of the Western Producer, and I'll be hosting and moderating this session. We'll hear from three speakers today. First, we're going to start with Justine Cornelsen. She'll take us through the how to keep blackleg at bay, and then we'll get weather and markets updates from markets farm experts Bruce Burnett and Mike Jubinville. Now, following as things roll out, following Justine's presentation, we'll have a question and answer session. And if you have any questions, please feel free to leave them in the chat on the right side of your screen. My left, your right. And for those who are looking to earn some CCA or CEU credit for this session, hey, please take a look at the right side of the screen, and you'll see the offers tab there, and there's a QR code to scan. So you can get your CCA credit there. You scan that with your phone, and it will log you into the CCA application, and that'll collect the credit, and you'll collect that credit automatically. If you're having trouble scanning your screen, there's also a printable version of the QR code and CEU details under the Files tab on the right-hand side of your screen there. So please note that you're only eligible to earn the CCA CEU credit if you attend the session live. Now, there's, of course, going to be a recording of this, and you'll get an email tomorrow. But if you're thinking that you're not going to attend live and then get that credit by watching it later on, the answer is no. So, but if you'd like to refer back to this content for those that are watching it, or if you have to hop off and you're not looking for those education credits, hey, it's you can review it at any time. And there's a lot of information, a lot of ground we're getting over, so it's a great opportunity to take it in on a second occasion. Now, our first speaker, as I said, is Justine Cornelsen. Justine is part of the crop production innovation team over at the Canola Council. That's where she covers western Manitoba, southeastern Saskatchewan. That would probably include my place south of Regina. And she's an agronomy specialist. Now, her lead topic with the Canola Council is blackleg and verticulum management, and she chairs the Canadian Blackleg Steering Group. Justine is also is a part-time master's student at the University of Manitoba in plant science. One of canola's most persistent yield robbers, of course, is blackleg, and it lurks in prairie fields. I've heard that neighbors might have it. Not something that would happen to me personally, of course. But Justine's going to review how to avoid giving this pervasive pathogen an easy path to your profits. So, hey, I'll turn it over to Justine, and let's hear what she has to say.
Right. Good morning, everyone. I'm Justine Cornelsen, agronomy specialist with the Canola Council of Canada, and today I will be discussing about keeping blackleg at bay. So for the course of this presentation, I'm going to review just, what is blackleg, how does it function within our cropping system here in Canada, and discuss the disease incidence and the prevalence numbers, so, how is it doing here in Canada and what type of impact is it having on our canola crops. We'll look at the yield losses. This is something that we've been able to capture now and have a better understanding of what type of losses we are seeing within the field. And then I'll discuss different disease factors. So with our, changing climate, is that favorable for disease development? Is that impacted? How does this pathogen fulfill its life cycle here in our cropping system? And then I'm going to highlight, obviously the most important aspect of this presentation, looking at how we can manage this particular disease. So we do have a bunch of different pest management practices that are available to help, minimize that disease pressure here and help preserve some of our yield. And that really is what we are looking for here, right? We want to be able to successfully grow canola without getting this severe impact from blackleg. So it's always best to start off with understanding this disease and the terms around it. So when we're looking at talking about blackleg itself, the pathogens that it's comprised of is Leptosphaeria maculans and Leptosphaeria biglobosa. And Leptosphaeria maculans is the aggressive type of blackleg. So when we're referring to the blackleg disease itself, that is typically the pathogen that we deal with here in Canada. So it is the aggressive type. The other subspecies or species that we have here in Canada is Leptosphaeria biglobosa. And biglobosa is known kind of as the non-aggressive. It comes in later in the season, so we just really don't see the disease impacts or is not able to create the really severe disease symptoms that we see within our crops. And so in the field, when we are looking for actual signs, so the presence of the pathogen itself, we'll be looking for things such as pycnidia or pseudothecia. And these are typically described as, the hard fruiting bodies, kind of pepper-like that will be over old canola residue. You can also see them within the crop as well. But that is the sign that you are dealing with blackleg or blackleg causing species. So like I said, Leptosphaeria maculans being the major contributor to damage here in canola. So as for the actual disease, right, this is considered the blackleg disease in canola. It is a brassica disease. So not only does it affect canola, but it also other brassica species. So when we look to things like wild mustard or our mustard crops, right, that would be another host crop for it. Disease or weed species would be, like I said, the wild mustard, stinkweed, right? They're all susceptible hosts because they fall within that brassica family. So when we're looking for the disease, the blackleg disease itself is typically summarized by stem cankering. And that is the severe component of this disease. The stem cankering leads to premature ripening, it leads to pod drop, and eventually a pod lodging, or plant lodging. And that's where we get our yield losses coming from, right? These plants falling over and not contributing to their full yield potential. So it's important to know that, and why I kind of highlight the difference between the two is we're going to be talking about blackleg race ID tests, so it'll be identifying which pathogen you're dealing with. And when we get into in the field and diagnostics and understanding, what's going on, right, we need to look at these symptoms. And a lot of these symptoms that I've highlighted here from the blackleg disease will be very characteristic to that of other disease symptoms or other stressors that these canola plants are taking in. So it's just good to kind of have a basic foundation of what's going on for both the pathogen itself and the disease. So any type of pathology talk always needs to go through the life cycle of the pathogen that we're dealing with. So right, like I said, the causal species here where we get a lot of our damage from is from Leptosphaeria maculans. So this is the disease-causing agent. And if we're going to work through this life cycle here, it's typically easier to start with the old canola residue. So with our high cropping frequency of canola, right, we've got a lot of residue out and in the field. And from there, that old residue will be covered with the actual signs of the pathogen, so the pycnidia or the pseudothecia, right? So those hard fruiting structures are all in that residue. And when the conditions are right, when we come into spring, when we've got some moisture and we've got the right temperature, they start to release spores. And they push up their spores up into the canopy, which then land onto the new canola crop. So typically in that cotyledon, really, really early on in development, the conditions are typically there for the old residue to be producing spores. And from there, right, you're going to have the lesions start to form. So lesions will start to form on those cotyledon plants, on those young canola plants. And from there, the pathogen has now entered into the plant. So it will move from the leaf tissue down the stem towards the base of the plant. Throughout the growing season, you can have this continue on. So from the lesions on the leaves, you can get rain splash or wind events that will blow further spores onto other material or further infection within that particular plant. So from there, that's a secondary infection, but they're all working towards moving towards that base of the plant. So as the plant continues to mature, the pathogen moves down the stem to that root, right at the base of the plant into the root tissue and causes this constriction. From there, that's where that constriction will start to cause plants to fall over. So that constriction doesn't allow any moisture or nutrient uptake. And that's where we start to get the roots starting to pinch off. You also have the plant starting to lodge then. you also have them starting to prematurely ripen and drop their pods. So right, that is really the detrimental piece. And it's important to understand that the infections or the disease severity that's occurring at harvest time or later in the season started first thing in the spring. And so when we typically go into the field and look for it is at harvest time, or that 60% seed color change. That's where we're able to assess the damage. So when we move over and looking at the disease severity, like I said, we want to calculate how much damage is occurring. So where we do this is at a typical canola disease surveying time. So the rough recommendation is 60% seed color change or prior to swathing. If you go later into the season, it becomes very, very difficult to tell the difference between the different diseases out there or the symptoms that the plants are suffering from. So at that 60%, it's typically cleaner and a little more obvious to see where the damage is occurring. So at that time, you want to pull up plants, you want to assess them for lesions. Typically, they're tougher to see, but you are going to cut through the root tissue and determine the percent of internal infection that way. So by the percentage of blackening that's occurring. So this is the disease severity rating scale for blackleg. So plants are rated on a 0 to 5 scale. So plants that have no blackleg will be perfectly clean right through that root tissue, no internal blackening. And then from there, it's just going to increase in severity. So a rating of a 1 is from 1 to 25% blackening across that cross section. So about a quarter of that cross section is showing blackening. And then we increase all the way to a 5, where that tissue right across is completely black. Typically, you will have the stem cankering occurring, so you'll have visible lesions where that infection is obvious, and you can see where the plants have been completely pinched off. So it's really important to understand the level that you're dealing with in your field, and why this is really important is we all know, right, that canola, our Canadian canola, more than 90% of it is exported. So when it's in shipments, right, we really want to make sure that we're reaching our market potential and our market requirements, right? So we want to keep the shipments of canola seed going out to be really low and small amounts of unacceptable residues, right? We don't want any of them in there. We want low levels of Leptosphaeria maculans, so that blackleg causing pathogen. So we don't want any of them to go in the seed as well. And also we got to watch out for things like deregistered varieties. And that's really the whole initiative behind the Keep It Clean program. Right, it is getting our product ready for market, and because the species that causes blackleg, that pathogen Leptosphaeria maculans, has been identified as a high risk pathogen, and to some of our consumers, where our export markets that are taking in canola, they do not want this pathogen to be introduced to their production areas. Right, so this is why there is a focus on managing blackleg here in Canada and keeping it at very, very low levels, so there's a very low risk of it ever being transferred with some of our seed shipments. So if you're looking for further information, definitely go check out the Keep It Clean website, which is at keepingitclean.ca, which will look at all the market access components and how we need to be meeting those standards and providing this high value crop in the end. So this is where there's a focus. And so in Canada here, what we do is we measure the disease prevalence and the incidence. So each year there are provincial canola disease surveys. So the provincial governments run these surveys. They typically weight the number of fields that are surveyed based on acres of canola. So I'll use Manitoba for an example. That's where I'm from. Right, the RMs that have more canola, there's more fields than surveyed to determine the level of different diseases. So not only blackleg is covered, but sclerotinia. They look at things like aster yellows, root rot species, verticillium stripe. All of these diseases are captured within this survey. But what I'm showing here is the prevalence data. And what prevalence data is actually out of all the number of fields surveyed, how many fields were showing symptoms for blackleg. And like I said, this is something that's been going on for over 20 years now. I do have the 2020 data in this particular graph, but it is preliminary. The results are not finalized until they're published in the Canadian Journal of Plant Diseases. So that's something that or the Plant Disease Survey, which comes out in early spring. But you can see that we've got the different provinces broken up. So we've got Manitoba in yellow, Saskatchewan in red, and Alberta in blue. And then the average. So just averaged out across the prairies where our prevalence would be. And typically we're around that 70%. The last, 5 years or so, that's where we've been around. You can see we've taken a few drops, and this is probably due to some of the really dry conditions that we've been having. 2019 was a really dry year, and we didn't have the moisture that was needed for this pathogen to really get going. So it took a little bit of a drop off there. In 2020, same, hot, dry summers, but we did have some spring moisture to get the disease going. So we did see some increases in Manitoba and Saskatchewan, which is going to tip this average back up a little bit. So we are around that 70% of fields surveyed showing blackleg. So we know it's here, we know it's present, and that's why obviously we talk a lot about it. That being said, when we start to look at the incidence, so the incidence, when we're looking at our plant disease survey or canola disease survey information, the incidence is the percentage of plants within the field showing the disease symptoms. And this is for all of the fields surveyed. So even fields that don't have blackleg in it, they're included in this numbers, right? So you're going to have a bunch of zeros in here. So really our overall incidence is relatively low. So that being said, the last 10 years, we've been around that 10 to 15%. So if we went into a field and we're determining the level of blackleg, 15% of the plants, or if we looked at 100 plants, 15 of them out of that 100 would have been showing the blackleg disease or blackleg disease symptoms. So over the last 10 years, like I said, in that 10 to 15% range. However, we've come up over that last 10 years. And, when we look back into the 2000s, we were under that 5% mark. And that's really where we want to be back at. So what's going on here? Why are we seeing this general increase in disease pressure here? One thing to note, blackleg resistant hybrids come to the market in the late 90s. So once they were deployed on all acres, right, we really took a decline in the pressure of blackleg out there. We were able to really manage it. So there's a few different factors probably contributing to this recent increase over time. And really we look at just production numbers overall, right? We grow a lot of canola now, right? So we're growing the crop that's susceptible to the disease. We're growing it in tight frequencies, so we're building up inoculum within the fields, and we're seeing also shifts within the actual pathogens in the field, or the races of the pathogen in the field. So there's a few different things here to contribute that, and that's what I'm going to dive into a little bit further and show some different ways to manage. I did just want to highlight the production impact, and so this is actually just a summary from Stats Canada Stats Canada production numbers, and then also comparing it with our canola disease survey numbers. But what this graph is showing is just our total production. So the yellow bars in the back are our total production based on acres, and this is done through harvested acres. So you can see in 2020 we were just over 20 million acres of harvested canola here in Canada. The black bars are the disease prevalence. So when we look at the disease prevalence, and I only did this for Manitoba, Saskatchewan, and Alberta, but you can see, right, we're about 70% of that crop would have had blackleg. But like I said, that's through the survey data. So 70% of that is showing blackleg there, but at extremely low levels. And that's what the red bars are here. That's the level, the incidence level. So you can see actually out of all of our crop, there's really, I think it was only 2 million acres that actually would have had blackleg itself. So if you looked at all the patches of incidence, and they're really, really tiny. And we know that, right? We know the disease is here, but we know it's at really, really low levels. And we want to keep it that way, right? We want to bring it back down to under that 5% mark. So this is just to kind of help visualize, how much of that crop would have potentially be infected with blackleg. So low risk for the most part. But that being said, there are extremes, right? So there's producers that are struggling to manage the disease, or they have these worst case scenarios, right, where they do get some really significant yield losses. And typically what's going on in these extreme fields, so this is an example here, right? You can see these large patches that have prematurely ripened. You can see the patches in the field that have fallen down, that are lodging already. When you pick up the stems and actually look within the field, right, this is what's going on, right? We've got all of these plants showing internal blackening, so showing the blackleg disease itself, and at some really high severities, right? Here's a plant here that would be rating at a 4 or 5 almost. So right, the level of infection is there to cause damage. So in these particular fields, right, where we're typically dealing with the perfect environmental conditions for the disease to do well, we're seeing these on high canola frequency areas, so areas where there's a lot of canola. This particular field has been canola wheat for a considerable amount of time. We're also indicating shifts within the races. So within that Leptospira maculans pathogen, we're seeing these race shift and adapt to overcome the genetic sources that we've been providing or using, right? So if we continue to use the same thing over and over and over again, we start to see these shifts occur, and the pathogen outsmarts what we're doing in the field and overcomes it and causes disease. So why this really matters, right? We've indicated obviously on a trade perspective, but the yield loss, right? So what is impacting, that grower's bottom line? And that's what we're seeing, right? We are seeing significant yield losses. So within the last 5 years in Canada, we've had a few different yield loss models come out. And this was one of the first ones done through the University of Alberta, Dr. Steven Strokoff and Dr. Shofang Wang. And what they were showing was, every unit that you increased in disease severity, so moving from a rating of a 1 to a 2, you were seeing anywhere from about 17 to 22% yield loss per seed, or like per seed weight per plant. So right, we're seeing these losses occur. So every unit you would increase, you would see an additional roughly 20% yield loss, and it would just continue up that way. So this was the original model. It obviously makes sense, right? The more disease you have, the more yield loss you would be losing. The model was just recently updated again, and same out of the University of Alberta. This is recently published work, and it did a little shift with it. And even in that original work, there was this notion that, a low disease severity rating of a 1 probably isn't impacting your yield that much. And that's what this new model is showing. So we've got the disease severity on the bottom right, the 0 being clean, healthy plants, 5 being completely, usually dead plants at that point, and the decreases in seed yield, or the seed yield lost. So as you can see, really, when you have a low disease severity of about a 1, you're not seeing anything lost from it. It's when you get up to a 2 where you start to see losses. So that's where 20% seed yield is lost from there. And then every unit that you increase in severity, that 20% is occurring. So a little bit of disease is okay. It's once you hit that threshold point of 2 where you start to see losses. And just for everyone's sake, when we look at disease severity for blackleg, typically we are around this 1. So the provincial ratings are usually 1 or less, right? So we know it's in the field, we know it's there at really low incident levels, and it's also there at low disease severity levels. So that's a really good thing, right? It's not taking a lot of our yield. It's only on those extreme fields, right, where we are seeing some losses occurring. So I just wanted to highlight some of our yield work, and it actually really overlays well when we start to compare it with these kind of high pressure blackleg years. So this work, is just taking StatsCan yield information, and this was summarized by Dr. Malcolm Morrison, but it's just a really neat perspective to look at it. So we've got the years across the bottom. We've got the yields, both in kilograms per hectare or also bushels per acre. So I'll use the bushels per acre axis. But really what you're seeing is this slope, and there's a linear trend with yield. So over the last 20 years, we typically see the yields of our crops increase by a bushel an acre per year. So this is based, this work is done with a 95% confidence level. So if the dots fall outside of those levels, they're either below average or below normal or above normal. So the red dots are the below normal. So right, this is where we should have had higher yields, but we had lesser. And same, the green dots are the above normal. So when we looked at 2020, it is actually a red. It was a below normal year for us. Right across Canada, we were averaging just around 40 bushels an acre. So this was considered a below normal year. And when I looked at some of these other dots, 2012 and 2013 were both below normal yield years. When I overlay that with the blackleg incidence numbers, those were high years for blackleg pressure as well. When I looked at kind of some of these above average years for 2013, 2016, they were great years. We had awesome yield. We also saw declines in blackleg. So there's a few different things going on there. And when we start to compare it, so I'm going to take this yield loss or this yield work and then apply it to temperature. And so saying this is what Dr. Malcolm Morrison had put together for us, and it is just a fantastic visual to look at. And on these below normal years, so following that red line, we have more or hotter or warmer temperatures in the early spring. So we see warmer temperatures in May and June. We also see them through July, and then they start to tail off in August and kind of become the normal. So we are seeing hot temperatures in the spring. And I make note of this because this is what blackleg needs to do well. All right, it needs warm spring temperatures for that old residue in the field to start producing spores. So we are seeing that on those below normal years. So they're below normal yield years, but they're perfect years or perfect temperatures for blackleg to be producing a lot of spores in that field. And similar things happen within the precipitation. So when we look at the precipitation map, so same thing, right? We've got the below normal years in red, the above normal years in green. They both start off with actually a lot of spring precipitation, higher than what we see in a normal year. So that's great, but we're seeing that for both below and above normal years, these higher precipitations. So what I would consider those below temperature, or those below yield years, that's where you're also seeing a lot of precipitation, which also is very favorable for disease development, right? Blackleg, the Leptosphaeria maculans, it needs moisture and it needs heat for it to get producing. So even though we're getting that moisture, which looks fantastic, and obviously our above year crops are really enjoying that as well, but it gets the disease going. So that's probably why we see a bunch of these below normal yield years having lots of precipitation, because then it really gets a lot of our diseases going. And not only blackleg, right? We got to look at other diseases like clubroot. It does well with lots of precipitation as well. If we've got that soil moisture there, it's likely that a lot of our disease-causing species are going to be doing well in producing spores. And so that's what I'm going to kind of dive into, is the disease development. What actually needs to occur for the blackleg pathogens to be producing spores and causing that new infection. And really, this is where that temperature piece comes into play. Early in the season, that old residue is going to produce some ascospores. They are typically released at that 8 to 12 degrees. Right, so they need those spring temperatures. So that's why the higher spring temperatures are going to create a lot of opportunity for the pathogens to producing these spores. They also need a lot of humidity, right? So that's where the moisture comes into play. If we've got that humidity there, we've got that moisture, it's going to be very favorable for the pathogen to be producing spores. And it doesn't take a lot of rainfall. So I think back to 2020, right? It was fairly dry for the most part, but we did have a few scattered showers, enough to get this pathogen going and producing spores. When we look to the actual lesions, so this here is indicating some lesions on the leaves, what we're needing are these warmer temperatures. Same, there's a huge range here, at 4 to 28 degrees. So same, we're hitting that each spring, no problem. It's just making sure we've got the conditions to get the spores producing. That being said, it takes some time for these lesions to develop. And the temperature is going to impact how quickly they start producing lesions, and when those lesions will be able to start creating that secondary infection, creating further infections in surrounding plants. As we move through the summertime too, right, we are seeing hotter temperatures, especially in July and August. And what's going to occur there is then the canker development, right? That pathogen has moved down the stem to the base of the plant, and we are seeing these warmer temperatures, which are very conclusive for the cankers to start to form and where we start to see our yield loss. So we have been having conditions for blackleg to do really, really well in. So best management practices. A lot of these haven't really changed. Some of them have been tweaked over the last few years. But the nice thing when we look to blackleg management is we've got a lot of options available, which is huge. And so I'm going to work through each of these. There's 5 kind of main best management practices that we focus on when we're talking about, managing this particular pest. And I'll get into a little more detail when we get into something like the stewardship of resistant sources. So that would be one of the new ones, right? We've always used resistant hybrids. Now we are looking at, better understanding the resistance that we are using and making sure that we can, increase its longevity or increase the longevity of a lot of these products. And then one other new piece is fungicide use. We now do have products available in a seed treatment form to help manage blackleg. So yeah, I will get into that into a few details. So I will work through each of these. So the very first one obviously is crop rotation. So our canola rotation frequency. So how often, is there a canola crop on that particular piece of land? If it does have disease, is it increasing in inoculum levels within the field? And this is work that was done at Ag Canada, Lacombe, with Dr. Neil Harker's group. And what these graphs are showing here is, your blackleg incidence. So, right, the number of plants infected within these plots, and then the years between the canola crops. So the first year in 2010, when they did this, it was only based on 3 years. And so when you've got continuous canola crops, so 0 rate, you can see you already start off at a higher blackleg incidence. If you allow 1 year break, right, that incidence starts to move down. And as you increase to a 2 year break, same thing, the incidence levels move down. And as they increased in more years, so 4, 5, and then 6 years, you can see in 6 years, that level of blackleg incidence already started higher off for the continuous canola. Right? It's been building. The inoculum has continued to build within the field, causing more disease pressure. And as you even increase out of 1 year, you're seeing these significant reductions in inoculum levels and then resulting in lower disease pressure within the canola crops. So we know this, right? This is something that we see in all crops, all diseases. If you're able to extend out that rotation, you're really able to minimize the disease pressure within the field. So that is something that we've always focused on. The recommendation is at least 2 years break. So in Manitoba, I always think too, right, if you can go canola, wheat, soybean, canola, that 2 year break is enough time to allow most of that infected residue in the field to break down. Blackleg is a stubble-borne disease, so it needs that old residue for it to survive on. So the longer period of time to allow that residue in the field to break down, the better off you will be. And so that's why crop rotation is one of the, if not the most important thing when we look to manage blackleg. Crop scouting. This falls obviously same thing on a lot of disease management aspects or pest management aspects, right? You've got to be in the field and you've got to be looking for pests out there. You've got to know what you're working with so you can deploy a bunch of these other management practices. Blackleg can be a little difficult because it shows itself in many different ways, right? Early season, you can be looking for the leaf lesions. As you progress throughout the season, you'll start to see that stem cankering or that constriction. When you cut open the root tissue, you can identify the internal blackening. But this internal blackening can also look very similar to other diseases. When we think to diseases like different fusarium species, or if we think to verticillium stripe or verticillium longisporum, they're going to look very similar. So it's training your eye to properly identify the pathogens and the disease-causing agents within the field so you can deploy other management practices. One of the easiest ways to identify blackleg is looking at that old residue. The old residue and actually finding the physical signs of the pathogen itself will help indicate that you are dealing with Leptosphaeria maculans, which is the disease-causing agent of blackleg, right? So it's going through that motion and knowing what you're working with. What we, I guess, rely heavily on here in Canada is the use of resistant hybrids. So in Canada, everything that comes to market is either resistant or moderately resistant to blackleg. And that's something that's been in place for almost 20 years now. So we're doing kind of step number one, we've got that covered. But now, because of the shifts that we're seeing from the pathogens in the field, right, now we're really diving into and understanding the types of resistance we are deploying here. And so I'm just going to work through this little graphic here. So starting on the left-hand side, when we have no resistance, so when we use something like Westar. Westars are susceptible, it's got no inherent resistance of any type to blackleg. This is what we use to determine the levels of blackleg resistance in other hybrids. But what happens here is when it's infected, right, there's no resistance, you get disease right away. When you use something called major gene resistance, so major gene resistance is called many different things. I'm just going to stick to calling it major gene resistance. And it kind of works like a light switch. It's an on or off thing. And if the correct races of blackleg are in the field, it will match up to them. And if it is a match, it will create this complete defense response. So it initiates a defense response within the plant that stops the pathogen from entering. So it doesn't allow the pathogen in, it doesn't allow it to fulfill its life cycle, it doesn't cause any sort of infection when it matches. So it is very race specific. If there are other races in the field that are able to overcome it, that's where you get disease in these particular hybrids, right? So we're not getting that complete defense response anymore. When we move to something like quantitative resistance, and quantitative, when we look on the market, is called many different things. It's referred to as adult plant resistance. You'll see it marketed as QTLs, minor genes. And really what this, I'll refer to it as quantitative resistance. What it is it's broad spectrum. So it's a lot of different genes working at slowing the rate of infection. So it does allow the pathogen in. That's one really big difference between the two groups, between the major gene and the quantitative resistance. Quantitative really works at slowing down that rate of infection. As the pathogen moves down to the base of the plant, that's where it's going to work and slow it down. And probably why here in Western Canada, we see a lot of fields that have blackleg, but at really, really low levels. A lot of these quantitative resistance genes are working at slowing it down. So in the perfect world, you want a hybrid that has both an effective major gene, so a major gene that's going to match the predominant races that you are dealing with in the field, but also a really strong quantitative background. So when you have both of them together, you've got this kind of complete line of defense, and it helps to really suppress the disease pressure in the field. I wanted to show this graphic because I am going to focus on the major genes. This is an area where we've had some recent developments in within the last 5 years, and so it's important to understand how they work effectively. When we look to something like quantitative resistance, it's something that the industry is working on. It's not easy to understand, it's complex, and we're not at the point of really identifying it yet. We can't compare between two hybrids, or we don't have a labeling system in place or a way to measure the quantitative potential within the plants. So that, like I said, it's something the industry is working on, but we're not at the point yet of having something where we can, quantify that quantitative resistance. So with the major gene resistance, so if this was our canola hybrid, it was containing a major gene, it has to match up to a virulent allele in the population. And I'm going to get into this in a little more detail when we talk about race ID tests. But what's going on here, what's occurring is the perfect match. So when there's this matchup between the resistance genes within the hybrid and the virulence allele within our pathogen, you get defense response and no disease. If you are using the same resistance gene, but it's not finding a match in the field, so there's no avirulent alleles that match up, there's only aggressive alleles, so right, virulent means aggressive, you get disease forming. So even though you are growing a major gene resistant hybrid, you still get this infection occurring, right? So we got the disease developing here. And so when we're growing something that's not resistant, right, this is where you obviously get disease no matter what. Doesn't matter if there's avirulent or virulent alleles in the population, you get the disease forming. So what's occurring here in Western Canada now is, right, we're getting a lot of this, right? We're growing resistant hybrids that have got a major gene, but it's not matching the alleles in the population, or in that Leptosphaeria maculans populations. So what the industry introduced a few years back was a way to group our different major genes that are out there so we know which genes we are deploying. And this was only kind of one piece of the puzzle. So we've got resistance gene groups now. What the groupings do is they help to cover up a bunch of these behind the scenes interactions. So there's interactions between genes, there's interactions between the avirulence alleles. It becomes very, very complex. So that's why it's in a resistance gene grouping or identification system where they are classified by different groups. So some life science companies are identifying their genetics. It's an optional component for groups to deploy. About half of the companies that provide hybrids are identifying their major genes that they are using. So you will still have that resistant or moderately resistant rating on your seed bag, and then you will have your hybrids identifying the major genes that are deployed. So these are typically not on your seed labels. They will be in your seed guides or online. So this is where you would have to look for that type of information. But really, they're going to list off the major gene groups. So in this particular example, this one had 2 major genes, so B and C. So that would correspond to the major resistance genes RLM2 and RLM3. Like I said, complex information. But why we were really focusing on understanding the major genes deployed is there's a very clear interaction. So Leptosphaeria maculans works on a gene-for-gene basis with canola, so with our canola hybrids. So whatever major gene we've got in our canola, so a lot of them will have this RLM1, RLM2, that's what it'll be named. They correspond directly with the avirulence alleles within the pathogen itself. So they're recognized by the plant. So when the plant is attacked by these alleles, it can start off the defense response if there's a match. So if we're growing a hybrid that's got RLM3 in it, it will have to match up to the avirulence allele within the population to start off the defense response. If we've got this gene and it's we've got other races in the field or other avirulence alleles within that particular race, and there's no match, then that's when you're going to get disease. So it has to match up. There has to be at least one match for the defense response to start. So blackleg races is something that we're becoming a lot more familiar with. And races are clearly defined by genetics of the interaction. And so with blackleg, we have a really good understanding of what's going on. Especially over the last 10 years, we've come leaps and bounds with understanding the gene interactions, the virulence allele interactions, and how they work within the plant and also within the blackleg pathogen itself. And this is, when we compare it to something like clubroot, very different. Right, we are at this level of understanding where we've got a very clearly defined way of understanding these different interactions. And this becomes important because we are getting blackleg race ID tests now. So this is kind of the missing puzzle piece here. We know what's going on within a lot of our hybrids, so what major genes have been deployed. Now we need to understand what's going on with the blackleg races within the field. So within those Leptosphaeria maculans races, what is occurring? And so a standard blackleg race ID test will first look at if you're finding Leptosphaeria maculans, yes or no, right? That is the aggressive one. That's the species that's causing a lot of our yield loss. If it is detected, then the next step of the race ID test is to then determine the genotype and the phenotype. And for growers and agronomists, right, the focus comes back onto the phenotype. This is the physical expression of the races within the field. There's a lot of interactions that occur between the alleles. So what happens there is they're showing up in the genotype, but they're not expressing themselves in the phenotype. So that's why when we are looking to make hybrid recommendations, we focus on what the phenotype is. So what actual avirulence alleles are present in the population. So I just wanted to work through an example. Like I said, this is a very complex topic. It is a matching game. So once you've done it a time or two, it starts to resonate and make sense. Where you be using something like this or a test is, if you are seeing those really extremes, if you are dealing with, extreme pressure from blackleg, this is where you would dive into looking at what some of your hybrid options could be, 2 or 3 years down the road. So in this particular example, we've got 3 different races that are occurring, and this would be normal, right? You are going to see a few races be detected within your test. And from there, you want to look at commonalities. So you want to look at avirulence alleles that are within all of the population, right? If they're there, or you want to look at those with the highest percentage, because you will then be matching more of that population. So I'm going to use the 2 examples. Actually, we've got a virulence allele 4, 5, 6, and 7 in all 3 of these races that were found within this field. So we need to then look for corresponding resistance genes that will help initiate the defense response. And within this, here in Canada, we actually only have RLM4 and RLM7 available and labeled on our market today. 5 and 6 are not in the marketplace yet, or not identified, so they're not labeled. So we do at least have 2 options in this field example. So we need to look for groups that fall within that E1 and E2 resistance gene categories. And from there, I just listed off some of the hybrids that are available. Right, we do have a few options, as you can see here. So you'd be wanting to choose one of these particular hybrids to match the predominant avirulence alleles in that particular field. And when with what's occurring here is with that match is you're getting that defense response occurring. Same, you still will have a few races that'll be able to overcome what's being deployed, and that's where you'll fall back onto that quantitative background. So having that quantitative resistance to help slow anything that sneaks by that first major gene, which is kind of your first line of defense. So, like I said, over the last about 20 years, we've really come to understand what the Leptosphaeria maculans population has done in the field. And the best way to present this is it's not to focus on the races itself, but the percentage of avirulence genes or alleles in the population. And so we can see here the diversity. This is older work done by Randy Kuchar, which looked at isolates that were collected. So the pathogen that was collected between 97 and 2000 and in a period from 2003 to 2005. And we've got all the different avirulence alleles are out there. So in all of the isolates that were collected in this particular project, they all contained avirulent RLM6 or avirulent 6. And so we know it's there within the population. So over time, this has changed. So when we look kind of, move up a few years into an isolate collection from 2012, same thing, we can see the diversity. And typically we want to have a lot of these bars to be tall. We want to see them in 100% or in all of our isolates collected. That means we have options. We have options available there to match resistance genes too. One thing to note is most of our hybrids here in Canada contain RLM3. And you can see here within our population, right, very, very low levels of avirulent 3 within the population. So we're deploying a major gene that is not matching the predominant race profile out there, that avirulence profile of the pathogen. So it's a huge downfall, and we would note, because we're not matching it. So we're relying solely on that quantitative background to help suppress a lot of that disease pressure. And same thing when we kind of, fast forward here to last year, 2020, we've got, the avirulence alleles highlighted at the bottom. This collection is not as diverse. It was only based on blackleg race ID tests, so it's not as complex as something that would be done at some of the university or in Canada, where they also follow up with the greenhouse tests as well and look at an additional set of avirulence alleles. But this is a really comprehensive set to understand what's going on out there. And same thing, right? We've got a very small population of that avirulent 3 occurring. So we're looking to match to some of these that are in higher populations, but some we don't have that corresponding gene within our hybrids. But we've come a long ways. We really understand what's going on at the field level, and we're now taking that information. And that's really what when we're moving towards resistance stewardship and why it is a recommendation for blackleg management, is we know what's going on now. And right, we have a really good idea of what's going on between the pathogens, the Leptosphaeria maculans, and our hosts, or canola crops, or brassica plants. We know how that relationship works. We now have a good understanding of the pathogen race profile. So what that avirulence profile looks like in the field, what avirulence alleles are out there, what do we have to match to? And we also can measure our resistance genes, so our major genes within our hybrids. We know what is there, and that's why there was this push for the industry to identify those major genes so we can better steward them. We know that we've been using one gene alone, and we've used it for 20 years straight now. So on these high canola frequency areas, this is where you're going to start to see changes, right? We're getting these virulent, aggressive populations that are able to overcome that resistance gene. So taking all of this information, we can, we know what we're working with. Information is powerful, or knowledge is power, right? And so when you've got all this information, we can actually do something about it. And so that's why there's this push to now understand the quantitative resistance. We know what the major gene is, and we're able to match it to our races within the field. Now let's find a way to measure that quantitative resistance to see what type of levels of resistance we're able to get from our hybrids, and hopefully increase the longevity of a lot of our hybrids that are coming to the market today. So that is, once again, a really key piece, and something that has changed within blackleg management the last few years is really understanding this relationship so we can better steward our genetics. Seed treatment. So fungicide use, seed treatment. So this is, once again, one of the newer areas. So coming to market this year in 2021, there's a few registered products out there. that are available. The work that I'm summarizing today is actually from Dr. Gary Pang at Ag Canada Saskatoon. So he was testing one of these seed treatments, and what happens here with the overall fungicide use, there's always been a component there to manage seed-borne transfer, which is extremely, extremely low, right? Because we do cover all of our canola with a seed treatment, with a fungicide seed treatment. So the risk of transferring blackleg or Leptosphaeria maculans within a seed bag is none, because we're already treating with it. That being said, our seed treatments were not systemic, so they're not protecting the plants as they were growing. And so this is where some of the new products coming to market will help at that. So one of the products that has been launched is Sultro Syngenta. And what a product like that is doing is it's helping suppress any sort of early season infection. So it's systemic, so it's taken up into the plant and should protect the plant, cotyledon 1, maybe even 2 leaf. And so Gary's work was looking at a different active that's will be available soon as well. But saying this is what this seed treatment was able to do. And so this in a greenhouse study, you can see the plants were all inoculated. Group D here was one of the products that had a seed treatment to manage blackleg. So a systemic seed treatment, right? Complete control. And you can see that here on the infection severity on cotyledon, same thing. No disease able to form on it. So this is something that's really exciting because it's going to protect plants at this really critical window for infection. Right when that infection occurs, cotyledon to a 2-leaf range, that's when you get the yield loss come fall, right? It allows that pathogen to move down the stem and cause that stem cankering. So a really important piece there, as it is allowing complete disease control. And where they saw a product like this pay off in Gary's work and actually work at the University of Manitoba as well, when you were growing something where the resistance genes were not functioning, when the resistance was not matching the predominant races, a product like this would pay off in the end because it was protecting it at that critical window. If you were growing a resistant hybrid that was matching your resistance or matching the races within your field, it didn't pay off because the genetics were doing all the work anyways. The seed treatment wasn't. So this is something that, it is coming available to market. It's a new option for growers, something to consider and to look at, especially if they are dealing with some of these blackleg extremes. Foliar applications have been available. They've always been on our list of best management practices. Typically, they're applied too late, and I kind of put a little memo here, right? Timing is everything. Because blackleg comes in so early, we've got to coat the plants with foliar products before the infection starts. So, right, cotyledon to 2-leaf stage. A lot of jug recommendation for products or foliar applications are usually 2 to 6. So a lot of them miss that really critical window for infection. And that's where a seed treatment is going to protect better off then, because it's actually already in the plant. So saying where you see the fungicide product pay off is when you've got that early application on, and when you're dealing with cultivars or hybrids that are not acting resistant anymore in the field. So that covers off our management practices. Like I said, we've got lots of options available, so it is so extremely important to use all of them together. We've really heavily relied on just the use of resistant hybrids, and that's how we're able to cause shifts within the pathogen population that are now able to overcome our resistant hybrids. So using all of the practices that are available will help minimize that overall disease pressure. So with that, I guess over the last almost 50 minutes of talking about blackleg, we are dealing with changing climate. So that's one of our our takeaways here, right? Where we're dealing with this changing climate, and it is going to affect how this disease works, when it infects the plants, how severe it will be. So we've got to work with it and look at things like that, like changing climate, and how we are going to better manage this particular pathogen. We know that crop diversity is going to get rid of a lot of the selection pressure on Leptosphaeria maculans, right? If we allow that residue in the field to break down over time, we're not going to have these severe shifts and changes within the races themselves, right? We've got to stop giving a host crop for this pathogen to take off in. And that really comes then into relying on our resistant hybrids. They work really well when stewarded correctly, but we cannot just rely on them and them alone, because, right, this is where these shifts are occurring. right? We want these genetics to survive and have a long lifetime out on the market, because we're running out of options, right? We can't just keep burning through them. So we want to preserve the genetics. So we've got hybrids to grow in the future that will match the aggressive or that virulent strain of Leptosphaeria maculans within the field. So lots of information, a lot of what I've talked to you about today can be found at blackleg.ca. And on the Canola Council website, we've got all of these resources available. The Canola Encyclopedia just had a brand new facelift. So lots of new information in there. And if you type in blackleg.ca, it will bring you to the disease page, or the blackleg disease page there. If you're not signed up for Canola Watch, right, that provides the timely kind of notifications and what you should be looking for and scouting for in the field throughout the growing season. So little tidbits on blackleg will show up throughout the season of what you should be looking for. And a lot of the research that I highlighted today can now be found up on the new Canola Research Hub. So lots of great resources. We partner here with the canola producer groups. So right, Manitoba Canola Growers, SaskCanola, and Alberta Canola, which I know are also partnering today on this webinar. Right, a lot of these resources are designed for growers, and so we have all available for the industry to use to help manage these different diseases. So with that, I thank you all for your time today. I think we're moving into a question period. So if you've got any questions that can't be answered during that question period, please feel free to reach out to myself. And I'd love to talk further about blackleg management with you.
I mean, what a great presentation. It really does hit home all of the challenges that are facing canola production, especially on the eastern side of the prairies, but I mean, blackleg is everywhere, and conditions have been, in many cases, we've gotten some pretty good crops off, but it's holding us back. It's holding back yields for sure. So this has been a yield limiting disease. One of the and I've only managed to get one question up so far, so I'm going to go from memory. But one of the questions that came up is, how can producers ensure that they're doing a really good job of sampling, so they can get those samples in and get some results, so they can make some decisions? And
yeah, the sampling was something I didn't get into a lot of detail on. It's something that we have been testing out the last few years. How a blackleg race ID test works is right around harvest time, you would take plants that look infected and submit them to a diagnostic lab or a third-party lab. So there's several different labs throughout Western Canada that offer the service. And what they're able to do is, from that infected residue, they're able to isolate off and confirm, first of all, yes or no, if you're dealing with Leptosphaeria maculans. And if you are, they will then determine the races. So as for sampling protocols, the best time is to go right when that canola crop is ready to harvest. If you collect samples later into the season or even the following year, there's a lot of outside pathogens that start affecting that residue as well. So it's tough to get a really clear isolate or a clear sample off of it.
Yeah, so it's and so the quality, good data in, good information out.
Yeah,
it's just good science on the farm. Now, producers, is there? So I mean, there's a question about Australia. Obviously, very heavily moved into using fungicide for control, and rather rapidly lost a lot of the effectiveness of that strategy. And so there's a question about how can Canadian farmers avoid that same problem. Of course, it always starts with a not snow canola rotation. But beyond that, I mean, relying on resistant varieties. I know you went over this in great detail, really fantastic detail. But if you could go into a little more or a summary of that, so how can we avoid and we don't want to be like Australians.
We're dealing with very different growing conditions. So in Australia, right, they do use resistant hybrids, and they also use a lot of fungicide products. So they are now using fungicide seed treatments, but they also use several applications throughout the growing season. They also have a longer growing season, so they will put several applications down. So the potential for resistance to build happens a lot quicker there.
Okay.
In Canada, because we don't typically use a lot of foliar applications to manage the disease, that pressure, that potential to become resistant towards the products is less. That being said, we do have some sensitivities. So you've got to watch when you're using the same active ingredient. So you might not be dealing with blackleg in that field. You might be dealing with, Fusarium head blight in your wheat crops. So you've got to watch out to make sure that you're not using the same actives over and over again, because that old canola residue will be in the field. So there is that potential there, and we have seen a little bit of sensitivity that way. So going through the motion and then obviously using a whole integrated pest management approach and in extending your crop rotation, you most likely would not have to be using those fungicide products.
Okay, and again, those are just great rules for stewardship in general. Rotate everything. Crops, rotate the herbicides and fungicides you use. Rotate, and profit from it. It's more work, but it's that's how, that makes it pay.
Diversity is a great thing. So if you're sick and tired of hearing about crop rotation, just think about crop diversity.
We're going to change that up right now in the Western Producer. We're going to no more rotational talk. We're talking about diversity here. So now we had a question about some of the manufacturers, BASF for instance, doesn't say what their resistance gene in bigger seed is. There's a question about so what is it?
So that's what we're all trying to figure out, right? And
yeah.
Some companies are not labeling it. It is a voluntary process right now.
Yeah.
So we've got about half of the companies on board, and really, right, it is up to individual companies, and they are protecting their germplasm or their lines. So, if you are an in-vigor grower, that's something that, you ask your rep about. They should be able to provide more detail for you. And if growers really want this information, right, the more we talk about it and the more pressure we can put on industry members, the likely they are going to start to label and identify the genes as well. And like I said, this is a new thing, and we're just trying to figure it out. And when you look to the Australian system, everything is identified just the way they go through their public producer trials or the co-op trials. That information has to be provided. So that's something that, we could explore here in Canada as well, making it more of a mandatory thing. And like I said, it's a lot of information, and it's still evolving and very technical, but it does provide value to growers. And that's really why we're encouraging industry members to move forward with labeling their genetics.
And in information, there is power. And it's always been thus, I think. Another question has come up as to, so you get a small rain event and versus, say, a larger 2 millimeters versus 25 millimeters. Why would you get a greater ecospore release on a 2 millimeter than, say, a 25 millimeter rain?
Yeah, so the work that was looking at the amount of rainfall or precipitation, that was just the minimum. So that's the minimum for that old residue to start producing ascospores. Some of those heavier events, you've got to watch out. It potentially could be too much or drown out the residue or put it underwater, where it wouldn't be as likely to produce those spores. So like I said, the 2 mils is just a base recommendation. Once you get that, yeah, it's the starting point. And same, if you get 5 mils or 10 mils, it's still going to be producing ascospores.
Now, and this, this applies across the prairies, especially as we start seeing some more extreme weather events. But I know, in that where our farm is, for instance, south of Regina, heat has always been the we're going to get those big blowouts of due to just a heat event that lasts for a week, and early on in the flowering or anywhere in flowering really. Yeah. But there's a question that says how much of this yield loss might be due to earlier blackleg damage versus, say, blasting a little later in the season. Any sense of a balance there?
Yeah, so when I was picking out, years where we had, below average yields and also had high blackleg pressure, right, there could be many different things going on there. Those were just some general kind of picking out some points along the production line there. But yeah, that's very correct, right? On those hotter years, right, you're going to lose stuff from blast. On those high rainfall years, you're going to have crop loss to sclerotinia or clubroot, right? There's a lot of different factors there. I think I'd pointed out 2012. 2012 was actually a really bad year for aster yellows in canola. So, right, the below average yields could have come from a wide variety of things. And really what I was trying to pull out there was actually just the correlation with increased blackleg pressure with some of the environmental conditions seen on those below average yield years.
Someone wants to know if Flipirum is registered and available for 2021 use for producers.
Yeah, so this, I believe it is not, it is registered, but it's not available for 2021. The only product that should be available for growers on the market coming this season is the Syngenta product with the Sultro. But same, I don't think a lot of life science companies have added it yet this year. It's still very new, and it got a late registration last summer. So I don't expect we'll see a lot of it deployed this year. But it is something that producers should have a look at. If we can get into crop tours and see it in the field, I would definitely recommend having a look at it and seeing if products like this would be a better option than a foliar application of a fungicide to manage blackleg.
Okay, and producers in Manitoba, Saskatchewan, Alberta, depending on which province you're in, or some of us have all of them, have a look in, because then there's registration updates that come up online as well, so with the various provinces. So have a look and take a look, because there are a lot of options out there if you're, when you're headed down those paths. And this is the time of year to be making those choices. So let's see if there's anything and there's a couple of comments about, boy, they'd like to see some, when they're registering varieties and we're registering hybrids, revealing the source of the genetic resistance should be a condition. So that's
it's something, on the canola front where we're working on, especially at the Canola Council, working with the entire industry and same, we're having the same discussions when it comes to clubroot genetics. So making sure that there's a standard, because there's claims and they're coming from all different areas and using different genetic terms. So it becomes very, very confusing to figure out what actually you need to be deploying on your farm for a canola hybrid.
Well, I mean, and your presentation has taken something that can be really confusing and made it a lot simpler to understand, and with tons of background in it. So we really appreciate it. Okay, it looks like the last of the questions. Thanks so much for joining us for this. Really, really great information and well delivered for the audience. So next up, we're going to have Bruce Burnett. And Bruce is going to be he's the director of weather and markets information from Markets Farm. And Bruce is going to be giving us some insights that we can help make some more decisions on. So let's hear from Bruce, and thanks once again, Justine.
Welcome to topics on today. I'm going to go outlook for seeds in 2021. Again, weather is going to be very important. We're going to be followed up by the market outlook by Mike Jubinville. So certainly this is going to be something that's very cool as we do the thing growing and harvesting of 21 crop. Anyway, I thought we were going to take a look back here to the growing season 2020. Because I think there's some particular things, especially regarding canola and the moisture status of the main canola growing areas, that's maybe a little bit different than, let's say, for wheat or for other crops like durum and pulses. So here's the growing season percentile. It's the entire growing season from the 1st of April to the 1st of October in 2021. And you'll see that the area I have circled is essentially from Red Deer up north through north of Edmonton and over into Saskatchewan, maybe a little bit north of North Battleford, up into the edge of the cropped area there. And you can see we were actually very wet, relatively speaking. Again, a lot of those rains fell earlier on in the season, so we did dry off at the end a bit. But overall, that was the area of the prairies that received above normal precipitation. If you look at other areas, especially eastern Saskatchewan, central Saskatchewan, over into Manitoba, the moisture conditions were not nearly as good last year. it resulted in some yield losses, but also has set us up to be looking at the soil moisture situation on the prairies as we go into this crop year. Now, take a look at Les Henry's soil moisture map. It was published in Grain News last week. The November 1st soil moisture levels, you can see there's an extensive area in the prairies, essentially from south of Red Deer down into the Medicine Hat area, across over into the Estevan Weyburn area, and then up to about Melfort, and then back across to Red Deer. This region is mostly very dry soil moisture conditions. There's a few spots that have better soil moisture, but the majority of that area has very little in the way of subsoil moisture reserves. So when we have crops in those areas growing this season, we are essentially going to have to rely on the moisture that falls during the growing season because there's just no reserves left. If you go back to that area that was wet that I outlined in the previous map up in northern Alberta, you'll see that we're actually in the moist area. We have essentially enough moisture there in terms of reserves to help us out for the growing season. So that's good news, and especially for canola growers up in those areas, I think it's something that certainly may help us in the upcoming growing season here. Although, to be blunt, as we go into the forecast, it doesn't look like it's going to be a particularly dry growing season this year. Winding off in that yellowish area, that's the transition area. It's still dry, fairly low subsoil moisture reserves. We don't have a lot there, and especially if we get caught in a dry spring, certainly those areas are going to be a concern. We take a look again at the predominant weather pattern that's supposed to be affecting us this year. It's La Nina, and the big question we have is, where are you? More or less, this winter so far in the prairies has been much above normal, which is not what a La Nina winter should bring. Just want to highlight a couple of things with this graph. This is sort of the typical weather pattern that you would receive during a La Nina. You can see the blocking high pressure ridge that is in the Gulf of Alaska, and it pushes the jet stream north and then brings down with it Arctic air into the prairies and the Midwestern U.S. Now, that's not been the predominant airflow this year, but over the next 3 weeks in February, that is going to be the predominant airflow. So we certainly are going to have a taste of winter here in February. We had a brief emergence of this pattern in January, in the third, fourth week in January, but it's returning now, and it's going to be much more persistent. So in past the middle of the month, past Valentine's Day, we're going to be cooler than normal here. The variable Pacific jet stream is actually the air that we've had mostly this year, and that's what's been giving us the warm temperatures over the winter and drier normal soil moisture conditions. So let's take a look at it. In terms of the La Nina itself, we really haven't seen a big change. There has been on the eastern side of the equatorial Pacific some warming of the sea surf temperatures, a little bit closer to normal now than they were, let's say, in December. But we're still solidly in a La Nina. The forecast for La Nina is that it's going to eventually transition in the spring and summer to a neutral phase, even hitting an El Nino phase as we move into the summer season. So that's we're going to go from a La Nina into a more neutral phase as we go into this growing season. The impact on temperatures, though, certainly hasn't been felt, as we were talking about on that the typical La Nina map. Above normal temperatures, northern growing areas, parts of Manitoba, Saskatchewan, Alberta, those areas are over 5 degrees above normal for the month of December. If we go into the January deviations, again, much the same thing. 5 degrees above normal up in the Peace River region, parts of northern Alberta, into Manitoba, where virtually all the province was 5 degrees above normal, as well as northeastern Saskatchewan. There were no locations on the prairies that were below normal or have been below normal over the past 2 months here. So that's pretty exceptional in itself. These deviations in January were exceptional. It's among the top 5 warmest winters that we've had, especially on the eastern prairies this year. You'll also notice an area that has in sort of west central Saskatchewan up into the Saskatoon area that's a little bit below normal. Actually, what that is the snow cover from the big snow events that we had earlier on this winter, because that region has far more snowpack than we have in other parts of the prairie. So that is impacting the temperatures significantly over the long haul here. So again, if we take a look at the moisture through the winter so far, again, this is percentiles through to the first of Feb. You'll see two areas that I've circled. First of all, east of Regina in eastern Saskatchewan and most of Manitoba, we've received below normal precipitation this winter so far. So that area that is quite dry or very dry certainly isn't picking up any moisture this winter. On the other hand, over in northern Alberta, you'll see that's also an area that's remained below normal this winter. But again, with that soil moisture reserve, it's really not as big a deal this year as it was. It would be in maybe years when we've had very, very dry subsoil moisture conditions. This is actually something I think that is positive here. Certainly the memories I think of most farmers up in northern Alberta over the past few years has been how wet it has been. And this actually might give us a chance here for a fairly normal planting this spring. But again, you'd have to cross your fingers and hope that there isn't above normal precipitation between now and the end of winter. And that's something that certainly I think is a feature of the longer term forecast. So this is the weather up until spring, so the remainder of winter into early spring. You can see that below normal temperature area, mostly in northern Alberta, northern Saskatchewan, maybe a little bit better chances of normal temperatures over that 3-month period into the south. But again, I think especially for the month of February here, we're going to see some temperatures that are quite a bit cooler than they were in January, which is not a typical winter, at least anyway, on the prairies. If you take a look at the precipitation over that same period, you see there will be a change in precipitation patterns as well. So that northern area, especially up in northern Alberta, that was quite dry, it looks like we're going to pick up a fair amount of moisture here in through April. So again, we could probably end that winter period up with close to normal precipitation for the winter. The southern areas of the prairies and then the eastern areas of the prairies sort of are looking more at normal rainfall or normal precipitation, mostly snowfall. But again, I think that's in those areas, that's a concern because again, the soil moisture situation is quite dry in those southern growing areas. So we've gone over essentially the situation in Western Canada, and for canola, I would say again, for the western growing areas, especially up in the northwestern, northern regions of Alberta, northwestern Saskatchewan, we have pretty good situation setting up, but we do have concerns for canola planting. Again, with the very, very dry soils, it leaves very little in the margin of error for canola planting. And I think in talking with a number of farmers, I think that's probably their major concern. We have high prices for canola, but the question will be, can we get the crops established in good fashion? But anyway, I think with that additional moisture that we're going to see across the northern grain belt, at least those northern areas over the next 2 or 3 months, we're going to see enough moisture to get the crop started. The other concern, and it has a primary impact on our prices here in Western Canada, is the situation in the Southern Hemisphere. And there's been concerns about dryness through the most of January and into early February here. There have been some rains since I did a major outlook presentation in January. The rainfall has been pretty beneficial to the crops, especially the soybean crops in parts of Brazil. We've seen mixed recovery in Argentina, but even they've picked up some rains. So the situation, I would say, is more stable there. The area I'm most concerned about is in Argentina. Those areas need some more moisture here as we're entering the sort of critical part of the growing season in the first 2-3 weeks in February. So it's something to keep a close eye on. Soil moisture conditions, although they've received these rains, really don't have a lot of subsoil moisture in order to help prop up crops there. Another concern has been about some rains in Brazil delaying the harvest. I would say, again, the rains themselves are a bit of a concern. I don't think they're a major concern here. The biggest thing to realize is that crop in Brazil was planted significantly later than it normally is. So the harvest is just getting going up in areas of Mato Grosso and some of the other northern growing regions. So that harvest will pick up here as we get into the second half of February and early March. So 2 areas to watch out for. If they do see above normal precipitation in northern Brazil, that would be negative. But for here now, I think those concerns are a bit overblown. Take a look at the percent of normal precipitation during the month of January in Brazil. You can see there's 2 areas that are really quite different in terms of what happened in terms of the precipitation. In the northern growing areas in Mato Grosso, Goiás, Tocantins, Minas Gerais, those states all have received below normal precipitation during the month. But again, as I said earlier, the timing has been pretty good for them. In other words, the timing in the first half of the month did provide enough moisture to help the crops fill out. So it looks like they escaped major damage there. The areas in the south are the ones that really have picked up a fair amount of moisture, with most of Paraná and Rio Grande do Sul being above normal to maybe normal precipitation. And the storm track over the next couple of weeks looks like it's going to provide a lot of moisture there. So that should provide enough moisture for the filling of the soybean crops in those areas. So I would put this crop situation in Brazil as being more stable than downward looking. Certainly I was far more concerned about it during the middle of January than I am now in terms of the overall production. If you look in Argentina, again, we've seen that mixed precipitation, again, from an area in central Cordoba over into southern Santa Fe. We had a little bit of above normal precipitation in the bottom area of that circle also, which is southern Buenos Aires province. We saw some moisture, but you can see there was still a significant amount of northern Buenos Aires, which is the chief producing region, that's still drier than normal through the month of February. Now, we did receive some rains in sort of the last week of January, and that's what the crops are living off of. But the forecast isn't that optimistic here until we get into about the middle of February. So that's a concern there I have for the crop in South America. If we take a look at the production estimates, here's the current production estimates for Argentina and Brazil combined together. USDA is currently forecasting 131 million ton crop for 133 million ton crop for Brazil, and total production with Argentina's contribution up to 181 million tons, which would be a record. I think that's probably a little bit optimistic. I currently like an estimate fairly close to last year at about 175 million tons. And that's basically because I think the crop conditions in Argentina have suffered from some of this dryness, as well as the Brazilian estimate, I think, from USDA is probably 2-3 million tons too optimistic. Anyway, it doesn't make a huge difference in the overall global supply and demand. A lot of the price movement over the next while will be this North American weather as it evolves, both in our canola growing areas and the U.S. soybean growing areas. If you want to take a look at that forecast here from February 3rd through 11th, you can see why I'm concerned about the Argentinian crop. Again, for most of Buenos Aires, Cordoba, southern Santa Fe, those areas expected to be significantly below normal precipitation here through into about the middle of the month. As I said, after that month, it looks like the precipitation is going to pick up. But again, that's still something that we have to keep a very close eye on in terms of the markets. So with that, that's the end of the presentation. I'd like to thank you for your attention, and we'll be seeing you later.
Okay. Well, thanks, Bruce. That's it's always good to know a little bit more about the weather, and you've given us a lot to think about when it comes to what's going on out there, and what's happening with that La Nina. Where did it go anyway? Now there's a few questions that people might be thinking they've got, and this is a great opportunity to take a look at the offers panel over there. Your offers panel has a place on it to be able to get in touch with the guys at Markets Farm and get it right from the horses' mouths. Didn't mean you were horses, but speaking of which, we have Mike Jubinville. Just kidding, Mike. Senior analyst with Markets Farm. Mike's going to be bringing us some information about what's going on in the markets, and we'll catch up with you after Mike's done with his presentation.
Hello, everyone. Thanks again for joining us today for a look at the developments in the oilseed markets. This report was recorded yesterday on February the 3rd, just in advance of Friday's Statistics Canada's grain stocks report, and next Tuesday, USDA supply demand report, both of which I think could have some implications both for canola and soybean markets. Hopefully, both those reports are going to confirm the very strong demand that we've seen for North American oilseeds to this point in the marketing year, and continues the tightening of ending stock scenario that we see for this year. Regardless, since August, we have seen one of the most impressive rally runs for oilseeds that we've seen in many years. So let's get a look at some of the things we're looking at. This is a graphic I haven't put up for the last couple of years, but I just wanted to make the point when we're looking at this that big rallies that we've seen in oilseed markets or cereal markets, this in case I'm using soybeans, but we could use canola, wheat, or corn. This graphic goes back to like 1987 or so, but rallies are punctuated by swift moves to the upside, shift quickly back down, and then we go through a period of 2, 3, sometimes 4 years of range-bound trade, sideways type range. And that's happened over the course of a number of different bull and bear type cycles. And you can see there where they have the two arrows back in 2015, 18 or so. I thought we were building after going through a significant up and down at the sideways period, getting ready for the next breakout to the upside. But lo and behold, the Trump administration initiated a trade war with China, and it dislodged a lot of the trade flow globally in the oilseed markets and cereal markets. So it kind of delayed that reaction. But certainly into the second half of 2020, we've seen coming late, but that significant upside that we've seen here. Now, when I look at a chart like this, trying to pick price targets in this kind of bullish environment, finding that level where demand curtailment in an element in a period of shortness of supply, trying to preserve that inventory, I think right now is really no more than a guessing game at this stage. In our previous outlooks, this goes back in the summertime in Ag in Motion with Bruce Burnett and I. We expressed the opinion that we went through basically 2 years coming into 2020 of kind of depressed crop prices, but felt that we were going into the new crop marketing year, that maybe we're starting to turn a corner to better times for 2020-21 marketing year, which is why this year at Markets Farm we took a fairly conservative approach in terms of our pre-harvest forward contracting of the 2020 crop. But at the same time, we, or quite honestly, nobody else could have foreseen the historic nature of the market rebound that we've seen since August. And, we've been scaling in sales in the post-harvest period into this rising marketplace. I suspect that the demand pull nature of this bull move is such that it'll probably still be able to be maintained for some time yet, and probably might even carry into new crop 2021-22. But that doesn't mean that prices need to charge to new highs every single day. They can and will have periods of significant retracement, and perhaps sharp ones, before all of this is truly played out. But certainly no room for crop threats today from the southern hemisphere, nor in the coming growing season in the northern hemisphere's major growing areas. So that's going to be something that the market is going to be very sensitive to. Soybean production, the last bars, the two segments at the bottom of each of those bars is Brazilian and Argentinian production for this year, and expectations that the combined Brazil-Argentina soybean crop is going to be anywhere from 176 to 181 million tons, as it's guesstimated so far this year, as early harvest is now underway. That beats last year's record of 175. Throw in, a larger than last year U.S. soybean crop, the soybean crop that was produced in 2020 over 2019. So we're still looking at a fairly sizable amount of production. But this is not about a shortness of supply in this year. This is about a demand-driven marketplace. And the market has been driven certainly by the vacuum cleaner-like approach that China has taken to a number of commodities, including oilseeds. So we're going to need all the soybeans and oilseeds, canola and such, that the market can produce. And part of the reasoning for that comes from a significant rebuilding of the Chinese hog herd, the largest herd in the world. China is quite partial to pork in their diets. But back in 2018-17 or so, when African swine fever decimated Chinese hog production, they are in a rebuilding process right now and have aggressively pursued that. So you're eliminating, I think, a lot of the more mom and pop type operations in the hog sector in China, and has shifted much more to large scale commercial type production. And instead of scraps or such that would be in the diets of the pigs in the previous environment, you're more on industrialized commercial hog production that requires more modern type feed supplements. So the demand for cereals, the demand for protein, on whether it's from the oilseed meals or from peas or otherwise that are going into the rebuilding of the Chinese hog herd, has been dramatic. And let's not forget that 2018 was the start of the U.S.-China trade war. So China was trying to minimize the best they could, making use of external supplies of feed ingredients for their needs in livestock production, as well as the human food sector. So they drew down significant inventories on cereals, oilseeds, and otherwise that are now relatively in short supply. And the buying interest from China on a lot of these products this year has been dramatically stronger and is expected to continue. And you can see that in this graphic here. This is U.S. soybean exports, shipments and sales so far this marketing year on the last bar, of record scale. And you can see the Chinese trade war with the U.S. and the effect that had on soybeans previously. But this is a demand pull trading environment. And right now, I would say that in terms of USDA's expectations for soybean exports for this current marketing year, 95% of those sales are already in the books, and there's still 7 months left in the marketing year. So a lot of the sales each year are typically in the first half of their marketing year, but still, like I say, the demand has been extraordinary this year, and so far there's not a lot of sense that that's stopping. And in fact, this is for old crop, this graphic I have up here, but there is evidence showing up quite regularly on a weekly basis now that China is already being very aggressive in booking from the U.S. soybean exports for next year's crop already. So, like I say, I don't think this demand environment is something that's going away anytime soon. Now, this has had a very dramatic impact in terms of U.S. soybean ending stocks. In the January USDA report, USDA was projecting ending stocks down to about 140 million bushels. On Tuesday coming up, USDA is going to be coming out with their next monthly supply-demand report. We'll see what it has to say, but certainly there is justification there for U.S. to be increasing their estimates, what they're using for exports, as well as their own domestic crush based on the usage we've seen to date. So could we curtail this all the way down to maybe 120, 100 million bushels, maybe even less? That to me is untenable. And effectively, the U.S. would be running out of supplies by this summertime, and raises the prospect that soybean imports into the U.S. may be required this summer. So a stocks-to-use ratio that's starting to drop below 3% is extraordinarily tight, and certainly calls for high prices to ration demand. From a chart perspective, this is the weekly soybeans. Going back to 2018 or so, we could see that there was a head and shoulders bottom inverted that was signifying a bottom over the course of almost a 2-year period. And when the breakout came and broke through the neckline of that chart, that formation, we obviously in the second half of 2020 undertook a significant rally. And again, we've blown through the targets that we would normally associate with a head and shoulders bottom, and have gone to the highest levels we have in the past 7 years or so on soybeans. We are in a period in the last couple of weeks in a bit of a consolidation period in the marketplace. It's pausing at the moment, deciding where it wants to go next. From a monthly perspective, if we're trying to make guesstimates as to where the peak of these kind of bull markets are going to be, really, I think it's kind of impossible to identify until well after the fact. Markets Farm will continue our program of incrementally selling oil seeds, whether it be soybeans or canola, incrementally into these profitable and rising markets. The resistance area, we paused here at $14 a bushel for Chicago soybean futures. Can we get up into that $15, $16 a bushel area? The fundamental suggests it's possible, but we are getting up into rarefied territory here. And so I'm presenting this as a bit of a cautionary position that we want to be in, because bull markets, they are born on pessimism, they grow on skepticism, they mature on optimism, and in the end, they die in a euphoric push to the end. So where are we at this stage on the scale? Well, we've certainly come a long way from where we were in the middle of 2020. So we should be mindful of that. So as it relates to more so to canola, this is a graphic on a weekly for soy oil. You can see that at the end of 2019, start of 2020, we kind of peaked out there. And I think the demand for vegetable oils, as inelastic as it is, in the sense that the user will pay almost any price because the product is that well sought after and needed, we had been starting a fairly significant trend higher, but then COVID hit, and threw all markets, whether it's equities, commodities, or otherwise, into a bit of a tailspin when we went into the first few months of 2020. Since then, again, we've bottomed out. I think there's a recognition in the COVID area that just-in-time delivery of foodstuffs was a bit precarious a position for a lot of countries to be in. So there's some hoarding went on, rebuilding of inventory. So the just-in-time delivery philosophy that's carried the agricultural markets for the past 20 years or so, I think got put aside as trying to rebuild inventories. And China certainly has taken the lead on that, but certainly there's other countries. But since that time, of course, the marketplace has certainly responded in bullish manner. And I kind of use soy oil as a bit of a proxy for me as to what to expect on canola. As long as the vegetable oil markets worldwide look strong, I think canola still has good underlying support underneath it. Looking at canola futures right now in the graphic, a long-term graphic going back to all the way to about 1985 or so, we can see this wedge that had been developing from the 2008 highs and a series of lower and lower highs, but also since that period of time, 2009, 2010, we've had a series of increasing lows as well. And again, I felt there was a breakout coming around 2018 or so until, when the Trump trade war came into effect, we kind of broke down a bit for a while, and for the past 2 years have been sort of trading a tight range at lower price levels until August of this year, when the breakout to the upside finally initiated. So we are definitely seeing a market that we haven't gone to only once in our history of the canola trade, and this is back in 2008. So from a production side, no real news here. StatCan, 18.6, 18.7 million tons in terms of the production that we did have last year on canola, less than I think the trade had been anticipated. So the crop conditions weren't as attractive in yield of the crop that we expected. But it's the demand side of the market that, again, is providing the leadership. And, we have canola crush margins are very profitable. This graphic here is using nearby months, minusing a big basis on the nearby positions, but includes cash pricing for where we are on canola oil, meal, seed, and otherwise. I don't want to treat this graphic of profitability in the crush as an absolute, but just on a relative basis, that's still telling us that crush margins, at least at this point in time, despite the higher seed costs, are still good for the crushers. And for export, the demand for canola oil also very strong right now. Canola oil is quoted at this point in time about 12 US cents a pound over soybean futures loaded boat in Vancouver right now. So a very strong demand component to the vegetable oils, and here in case of canola oil in particular. So in terms of overall crush pace for this year, I have it fairly close to what we did last year, and last year was a record. But the fact of the matter is, in terms of our domestic usage of canola at this point in time, we're about 100,000 tons or so ahead of where we were at this time last year. So this, to me, is certainly something I think maintains itself because it's strong. Crush margins are good. Can we match or supersede last year's crush pace? Yet to be determined, but so far we definitely are on track. But it's the exports that have my attention these days. The current export pace to the start of January, from the beginning of this current marketing year at the beginning of August to now January, at the end of January, is running almost 1.5 million tons ahead of what we were doing last year. And to me, that's not sustainable given the supply limitations we do have on canola this year. So if we keep running at the weekly pace that we are in terms of canola exports for this year, we'll have an export program in excess of 12 million tons or more. And that's simply not possible because we just don't have the seed to do it. So somewhere down the line, I think curtailment needs to slow. Europe is probably one market that'll probably slow first. Higher prices tend to discourage demand, and I think that process still needs to go through its ultimate conclusion yet for this marketing year. So canola exports, right now I'm projecting at about 10.25 million tons, slightly higher than last year, but pretty close. But like I say, the pace we're on now is 12 million plus, and to me that's just not even possible given the limited amount of seeds that we do have right now. Ending stocks this year, and again, this is based on curtailment of exports and a crush pace similar to last year, 1.25 million tons of carryout. And it's amazing where we've come from in just 2 years in terms of having an enormous excess of canola ending stocks to where we are now, where supply tightness is becoming rather dramatic here. So this is the key feature, I think, that is the underlying physical support for the canola market. Lower prices, it seems premature at this point in time. We're going to have gyrations in the market, certainly, and they could be violent when we're up in this territory. But the key underlying supply-demand features remain supportive until now. And canola relative to soybeans, certainly canola has made up some ground here in terms of its value relative to soybeans. but canola is still not considered expensive relative to its competing oilseed products. So canola still is competitive in the world environment. Here's the monthly graphic again. Again, this goes back to about 2008 or so. You could see this wedge that had developed between the highs and lows, converging to where we were to where we've become in 2020, and now leading into 2021. It was a delayed breakout after in 2018 when the U.S.-China trade war started, disrupted supply chains globally in terms of agricultural production and shipping, knocked prices down in 2018, 19, and into the start of 2020. But since then, of course, now we're looking at a significant breakout to the upside. And this graphic is kind of based on the continuation chart of nearby canola futures. So, right now the March contract is in the lead. Though I think from the commercial trades perspective, a lot of the commercial business has now probably shifted over to the May and July contracts. The March, to me, is becoming more of a video game as it approaches first notice day of delivery. So, but as what we're seeing, the internal structure of the canola market right now in terms of futures, they're inverted, which tends to be bullish, high demand for the product. That inversion is starting to come in a bit now, but in the cash markets, instead of an inversion, we're seeing a flat to a small carry going into deferred delivery, old crop delivery positions, as I think the basis is doing a lot of the real work in rebalancing the market right now. When I'm looking at canola, again, I want to look at soy oil, and that tends to be my proxy, given canola's dependence in terms of its overall value being determined by oil and meal. And with 60% of the canola seed being oil, it's very dependent upon what trends are in vegetable oil markets. We are seeing a soil market that has, rallied significantly, has tested around this 45 cent a pound area and stabilized a little bit. The underlying support at the 20-day moving average is a feature that I'm keeping in mind. Along the bottom of the graphic is the moving average convergence divergence indicator, and you can see where I've circled little corrective periods, and again, any significant rally is going to have periods of correction, but the overall uptrend in my mind still remains intact. So we'll look at May canola futures. Future spread still inverted. That's a positive. We're watching cash basis, for these sort of canary in the coal mine signals of a market that might be topping. But at least for right now, there's no clear sign, in my view, that a price peak is at work. But I'm watching here too that 20-day moving average on canola, as I'm on soil, as an important area of support that's carried right through the rally since it began back in August. And the other feature here in the shaded area of that graphic is the Bollinger Bands. And, when they widen quite significantly like this in a rising market, it tends to signify overbought conditions. That doesn't mean the rally's over. It doesn't mean that we're in danger necessarily of a quick fall in price immediately in the near term. But it is one of those indicators that say an overbought condition has been developing. And we're kind of in that territory right now where the bands are very wide. But like I say, the trends are still higher. Do I think we still have higher to go? I still think we are trend bullish. No clear evidence at top here, but I still want to be that incremental seller into that rising market, given the rarefied territory that the canola market finds itself in. So when I see $15 and $16 a bushel old crop, let's face it, I consider that a big win for the grower. And for us, that's paring us down to what I would consider gambling stock for the what ifs that we may have going into the last number of months of this marketing year. So I'm down to that maybe last 25% of unpriced canola from last year. I take the perspective that, you've got old traders, you've got bold traders, but it's rare to find a surviving old, bold trader. They tend to get killed off by taking too big a risks. And I think getting the business part of your canola sales done, paring down to gambling stocks, makes sense. The one thing I want to bear in mind here and make note of this graphic, this is a November 2008 So this is the last time when we saw canola futures eclipse the $700 area. Now, we had a significant rally in 2007 through the fall period into 2008, and we peaked out right at the beginning of March. And I remember this period rather significantly because, we had a significant turn down in the month of March. We dropped $150, $200 a ton on the futures. My phone was ringing off the hook. There was panic in the streets about what was going to be happening next in this market. I know there was a number of grain companies. They not only widened out the basis, but they pulled their bids entirely during this time. So eventually we stabilized, rallied a bit more going into the springtime, into the earliest part of summer before we fell off again. But I don't want to get caught in that environment. That's what my concern about is when we're into, like I say, this rarefied territory on the marketplace. So I'm not projecting this as the result for this year, similar to what 2008. The circumstances, there certainly are differences. We're going into a global financial crisis at that time. Hopefully that's not the case this time around. But certainly there are other characteristics in the market that are different. But again, just because there's only one other time in our history we've been this high, I want to exercise an element of caution and definitely reward the market with some very profitable prices that we see in front of us. Just a fast last note here on new crop. This is November canola futures for this year. Trending still higher. No immediate threat to the outlook at this point in time. Palm oil production growth is scheduled to increase in later on in 2021. La Nina has been helpful in bringing rains to Malaysia and Indonesia and such, so the palm production is expected to come on. But again, we're in a demand pull environment place. And I think the demand on renewable fuels, the overall vacuuming that China has conducted on cereals and oilseeds, I think continues later on into the year as well. So I think right now, in my mind, when I'm looking ahead at new crop pricing opportunities, I look at $11 a bushel or so as a potential floor for now. We are seeing $12 a bushel fall delivered opportunities about everywhere these days, as high as maybe $12.50 a bushel off the combine, maybe out in the West. And I got to be honest with you, that has me tempted to get something on the books, at least to get something done for off the combine deliveries for next year's production. But I also signed pretty good odds that over the course of 2021-22, we're still dealing from a tight supply scenario, even with the recovery in production globally. I still think $13 a bushel is not something that is off the table by any stretch. And if we have crop problems next summer here or elsewhere, well, look out, because the bull will get certainly energized in that kind of environment. Okay, so I think we need to be watching these grain markets especially close right now. The time constraints of doing this talk, but if you do have questions or comments on these commodities, we welcome them at Markets Farm. And of course, if you're not already a subscriber, please stop by for a free trial to our Markets Farm online service. That's marketsfarm.com. And you can give me a call or email directly anytime with any grain market questions that you have. I'd love to help you out. Best of luck to you in this marketing season. Stay safe out there, and thanks for joining us today.
Yeah, no, sell all of it. That's right. Yeah, no, let her all go. Yeah, sweep the bins. Oh, we're back? Oh, sorry, gotta go. Some good advice there. Thanks, Mike. That was some great advice on where the markets have been and where they're likely headed, and a lot of things to think about when it comes to this. As he said, any, especially on the canola side, anything that's left out there has some great opportunities. But as we saw in 2008, sometimes those opportunities don't last forever. So, well, thank you for joining our second session in Hot Topics in this commodity series this year. And stay tuned for more in the coming year. Our next session will be on February 18th, and we'll be focusing on soybeans. And I mean, as a crop, soybeans the acreage in Western Canada has been down a little bit, but there's some real opportunities, especially with some of the pricing that Mike was just talking about there. and there are significant opportunities for that crop outside of Manitoba. So, and well, thanks a lot, Bruce. Some great weather information, a lot of information to work with when it comes to marketing that canola crop. What kind of weather we're looking at, both on maybe on the disease risk side. And thank you so much, Justine, for helping inform us on that, and also on the yield side. You'll notice there's, of course, those offers on the side of the screen there. If you want to have any questions for the guys at Markets Farm, they really entertain hearing from you. And you can take advantage of a free trial if you're not already using their services. Thanks for joining us. We'll look forward to seeing you next time. It'll be soybeans, and you have a great day out there.